Hi everyone. In today's challenge, we are going to solve this problem. The problem name is permutation and the problem number is 46. Alright guys, so first of all, what we are going to do? We are going to clearly understand the problem statement. After understanding the problem statement, then only we will move to the logic part. And in the logic part, we are going to see how we can solve this problem. What is the logic we are going to use to solve this problem? So after understanding the logic part, then only we will move to the implementation part. And in the implementation part, we are going to implement our logic in Python, C++, Java and JavaScript programming language. Fine guys, and guys, if you want to have a look on the solution which I'm going to write in this video for Python, C++, Java and JavaScript programming language, I will share the link in the description. You can go through that particular link and you can find all the solution, right? Fine guys, now let's see what this problem say. So let's understand the problem statement. So guys, problem says given an array nums of distinct integer, right? So we are given first of all one input, that is nothing but an array, right? So we are given one array of integer data type, simple, right? Now what we need to do, we need to return all the possible permutations. Fine, you can return the answer in any order. Okay, that makes sense, right? Simple thing guys, just we are given one array of integer. Now what we need to do, we need to find all the possible permutations, and after that we need to return that all permutations, right? So if you don't know what is permutation, so let me just tell you. Permutation is a simple, like a math concept. So permutation, I think what we can say, we have to find all the possible way, or we can say all the several way. We can write here. Let's say this is a set of numbers, right? So we can say 1, 2, 3. These are the set of numbers, right? So we need to find all the possible or way to such that we can separate or we can order this set of number in a different way. In simple words, we have this set of numbers. So how many ways exist such that these three set of numbers can be arranged in a different order, right? Simple. So the first possible way is nothing but you can say we can do like this 2, 1, 3. So you can see guys, this is also containing only three these set of numbers, and but this is arranged in a different order. 2 is coming first, then coming 8, then coming a 3, and 3 to 1 is also a different, we can say different order, but it is, so this will also be called a permutation of this, right? So these both we can say set of numbers, or we can say this particular array is a permutation of this 1, 2, 3, right? And if I give you one more example, then you can say 1, 3, 2. This you can see also, this also containing only three number, 1, 2 and 3, and but it is arranged in a different way. First coming 1, then coming a 3, then coming a 2. So this is also a permutation of 1, 2, 3 only, right? So simple guys, a different ways, or we can say different possible way to arrange these set of number in a different order way, right? Different order. I hope it makes sense. So we have seen the what is permutation. So now what we are going to do, we are going to see how we can find all the permutation, right? So let's understand with example. So first example is 1, 2, 3. So we have 1, 2, 3 guys, right? So this is nothing but we can say our input, right? So this is our array. Let's say this is array. Now we need to find all the permutation of this array, right? So how many ways, we just need to find how many ways exist so such that this set of numbers can arrange in a different way, right? So the first way we have seen is nothing but we can say 1, 2 and 3, right? This same way, right? We can copy this particular way only because itself it is also a permutation of this three number 1, 2, 3, right? So we are going to return this much, this only as well, right? Second is nothing but we can say first we can put 3, then we can put 2, right? So we have just swapped this 2, right? And the third we can say 1, we can say simply 2, 1, 3, right? So I'm just taking from here only, right? You can see after that we can say 2, 3, 1. So you can see after 3, 1, 2, because now I have put 3 on the first place, 3, 1, 2, then we can say 3, 2, 1, right? So you can see guys, we go to 6, we can say 6 ways where all these three set of numbers are ordered in a different way, right? None of these array you can see are same, right? They are having a different order, right? They are arranged in a different way. So we are going to return not a count, we are going to return all these array in a particular array, right? We are going to return all these possible ways in a particular array. I hope it makes sense. In the output as well, you can see we got all these 1, 2, 3, 1, 3, 2, 2, 1, 3, so on up to 3, 2, 1. We are returning all these things in a output, right? But see guys, we can return in any order. So there is no current, we can say condition that you have to return in a sorted order, any other order. You can return in any order, right? This makes sense, right? So it's like you can return 1, 3, 2 later. You can return instead of 3, 2, 1 here. You can return 1, 2, 3 here, right? That doesn't will gonna give a false output, right? It will be also correct output. Fine. So we have seen the first example. Now let's see the second example. So in the second example, we have two length of array only, and that is nothing but 0, 1, right? So let me write 0, 1. Now we have to arrange in a different way, right? So first way is nothing but we can say 1 we have put ahead, and then we have put 0, right? And second we can say same only, right? 0, 1 only. So you can see we can only make two we can say array after arranging in a different way, right? So there are only two array present, so we are going to return answer in nothing but two array only, right? 0, 1 and 1, 0. I hope it makes sense, right? Third one is nothing but a single one array, so we have to return this only, right? There is no other way to present this array in a different order, or we can say in different way, right? So we are going to return one only, right? You can see we have written answer 1. So guys, simple meaning guys. I hope by this example you understood what we need to do. Simple guys, we are given one array. We have to find all the possible permutation. After that, we have to return all these possible permutation, right? Fine. So now what we are going to do, we are going to see the logic part, right? How we can solve this problem. So let's move to the logic part. So I'm going to write here logic. And see guys, in the logic, what we are going to do, we are going to simply use a recursion. And recursion is must for this problem. If you don't know recursion, if you don't know backtracking, don't worry, you are here. We are going to learn all these things here, right? Don't worry about that. But I'm saying that recursion and backtracking concept is very important for this particular problem. And yesterday also we have seen one problem, that is combinations. There also we have used a recursion. The same here we are going to use a recursion. But how? Let's see. So guys, I'm going to take a much space here. So guys, first of all, I'm going to try recursion tree, right? So we have nums array. I'm taking a first example, 1 to 3 example only, right? So we have this nums array. Now what we are going to do, we are going to find all the possible we can say permutations, right? So what I'm going to do, I'm going to say this is my recursion tree. Okay. All right. So what we are going to do, we are going to say this is my recursion tree, and here I'm going to say uh, this is my temp array, right? Let's say this is temp array, which is going to be in each in the recursion tree is going to be act like this: 1 2 3 3 2. This is a separate array, right? So we are going to say this is initially empty, right? So what I'm going to do, I'm going to here draw a recursion tree. So what I can say you can, this is empty array, right? So first of all, you're going to traverse all this nums array, and on each element you are going to insert in this array, each element, right? So you can see currently I have empty array, right? So I traverse on this nums array, I found one, so I have inserted one in this. I found two, so I have inserted two in this as well. So I found three, so I have inserted three in this as well, right? It makes sense, right? So initially I was having an empty array, but after that I got 1 2 and 3 in a separate array, right? Again I'm going to traverse on this 1 2 3 array. Fine, for this one, so you can see I can't insert one again. So I'm going to say when I was traversing over this nums array, I found one, right? But I know that one has already been inserted in this array, right? So what I'm going to do, I'm going to say okay, move ahead. So I found two. Yeah, two is not inserted in this array. So what I can say, I can say insert two, right? 1 comma 2. I found then 3. So all right, 3 is not insert in this array, is not already present in this array. So what I can say, I can say insert 3. So I have said 3, and I have removed the next line because we can only insert this 2 now, right? Same goes for 2. So I started traversing on this nums array. I found 1. 1 is not present in this 2 array. So I'm going to say insert 1, 2 comma 1. I found 3. Not I found 2, right? So 2 is already present. So I'm not going to insert it. I found 3. So I can insert 3 as well, right? So 2 comma 3. See, I'm appending this, right? I'm not inserting in anywhere. I am appending that particular number in our given array, right? Fine. Now I have 3. So I'm going to traverse again for this 3. So I found 1. So right. So I can insert 1 here. So I can say 1 insert. I found what? I found 2. So I can insert 1. Let me first of all insert 1. So I found 2 as well, right? So I'm going to insert 2 as well. I found 3. But 3 I can't insert because 3 is already present in this nums array. This array, right? Fine. Now let's move to the next level. So here I'm going to traverse 4 again 3 times for this nums array. So I say for nums 1, right? I found 1. So you can see 1 is already present. We can't insert it. I found 2. 2 is already present. We can't insert it. I found 3. But 3 is not present, right? So I'm going to insert 3 here. I'm going to insert only 3. 1, 2 and 3. Fine. Now here I'm going to see 1 is already present, right? We can't insert it. 2 is not present. So we can insert 2 here, right? So 1, 3, I have inserted 2 at the last, right? Here for 2 comma 1, 1 is already present in that 2 comma 1, right? 2 is also present in there, but 3 is not present. So we can say 3 here, insert 3, 2, 1, 3. Now come here. So 1 is already present in that. No, you can see 1 is not present, right? So we can insert 2, 3 comma 1, 2, 3 and 1 at the last. Is 2 is present in there? Yes, 2 is present. 3 is present. 3 is present. So we are not going to insert any other thing, right? After that come to 3 comma 1, and in 3 comma 1 we are going to see, but we are going to traverse for nums, right? So we're going to say 1 is present in this 3 comma 1. Yes, we can't insert this again. 2 is present. No, 2 is not present. So insert 2 here, right? So 3 comma 1 comma 2. Now here we can say 3 is also we can't insert because 3 is already present, right? Now move to this 3 comma 2. So in this 3 comma 2, what we are going to see, we are going to say is 1 present here? No, 1 is not present. So insert 1 here. So I'm going to say, so let me just scroll it out. Okay, fine. So what I'm going to do, I'm going to say okay, insert 1 here, 3 comma 2 comma 1, right? And can we insert 2 and 3? No, we can't insert 2 and 3 because they are already present in this array, right? After that, once this is done, now let's move ahead. Let's see what we can insert here. So guys, before checking to the nums array, before traversing to this nums array, we are going to also check whether the length of this array now is equal to our nums array. Yes, if it is yes, so we are gonna not we can recurse again. We are not gonna traverse again to nums array. We are gonna simply return, and we are gonna append this particular array in our result. So let's say this is result array. So we are gonna append 1 comma 2 comma 3. Then we are gonna move this, and you can see fine. This length is also equal to the nums length. So we are gonna not traverse on again. We are gonna simply append in our result. So we can say 1 3 2. and we'll keep doing for all these things, and we're going to say after putting all this number, we can say array in this result array, we are going to return this result array, right, which will store all the combination, all the permutations, right. And you can see guys, the count of this also 6, 1 2 3 4 5 6, and 6 they have written in the output as well, 1 2 3 4 5 and 6. I hope it makes sense. So just we have to draw a recursion tree, how this is going to work, right. So for each particular, we can say this node, so if you consider this as a node, so this is a node, this is a node, this is a node, right. So for each node, what we are going to do, we are going to traverse to the nums array, and we are going to check if that number is present in already in our array. So don't insert it, otherwise insert it and call to the, or we can say, and start solving again, right. Move to again a near recursion part, and we are also checking if the length is equal to the nums array. Don't recurse again. Don't we can say call the function again. Just simply return a, you we can say return here, and is also insert this particular array in our result array, right. So this was the simple recursion tree. So I hope you understood what how recursion tree gonna work. Now let's see how flow works, right. So let's understand the flow work, how backtracking gonna work here. So I know this recursion is quite easy, you can easily grab this one, but let's see the how backtracking was gonna work, right. So guys, what I'm gonna say, I'm gonna say simply write here nums array as well. See, nums is nothing but 1 2 3, this was the nums array, right. So let me just see my cursor where it goes. Fine, so we can say like this, right. Fine. So what I'm gonna do guys here, I can say it is my nums array, and first of all initially what I'm gonna do, I'm gonna say this is an empty, right. This we can say this is an empty array initially we have. So I'm going to traverse over this nums array, right. So you can see nothing is present in my nums array, so I'm going to insert it. So I'm going to first traverse to the 1. So I've inserted 1 in my this array, empty array. So I've inserted 1. So okay, now this will directly call to another function, right, same function. So it will also going to traverse this nums array, but before that I'm going to skip count that I was here at the 0 index. I have already taken a 0 index, right. Okay, now this will call to another index, this function same. So that function will traverse on this nums array. So I come to 1. So is 1 present here? Yes, 1 is present already. So we are not going to take it. Is 2 present here? Yes, 2 is not present. So take 2. So I'm going to append 2 here, and I'm going to say fine, I have traversed till the 1 index. Okay, now this also is going to call a function. So this will going to again come to this nums array, and you're going to traverse. So 1 is present in this array? Yes, 1 is present. 2 is present? 2 is also present. 3 is present? 3 is not present, right. So what I'm going to do, I'm going to say fine, just say 1 comma 2 comma 3, insert 3 at the last. Fine, now this is done. So I traverse here till second index. Fine, now what I'm going to do, I'm going to say okay, now before traversing, just check whether the length is equal to nums length or not. Yes, it is equal to nums length. Don't traverse it, just put this in a result array. So I'm going to put 1 2 and 3, right. Fine, now this is going to backtrack. So as this is written, this is returning from it, it's going to backtrack. So you can see we have inserted 3 here, right. We have inserted 3 at the last. So when we are backtracking, we are going to remove this 3 as well, right. So it will come to this 1 comma 2 again, right, and it come to 1 comma 2, and you can see guys, 1 comma 2 we have traversed till 1 index, right. So we have traversed till 1 index, this 1 index. So we haven't traversed the third index, so we are going to traverse third index, right. So on third index you can see 3 is not present in this nums array. Fine, so what we are going to do, we are going to say, let me change a different color. We are going to say append we can say here not this one, right. So this is just already done, this has traversed till second index. I was talking about this one, right. So this is going to remove 3, right, and we have traversed till second index, last index, right. So just what I mean by here, I have confused you here. So what I mean by here, this 0 index is for this one, right, right, and this 1 index is for this one, and after that we have moved to the 1 comma 2, right. So let me change the color. So really sorry guys, I have wasted up 1 minute for you, right. 1 comma 2, and this has been traversed for second index, right. Now what we were doing, we were moving to the 1 comma 3, 1 comma 2 comma 3. So simple, from that one we have moved to 1 comma 2 comma 3, and you can see guys, from here we have appended this in our result, and after that we have written this, right. So this will remove 3 from here, it has removed 3 from here. Now once this has removed a 3, so what we are going to do, we are going to say fine, we have removed 3. Now come back to this 3 has been removed. So now check whether any number is present in our nums array or not. So you can see guys, we have traversed till second index, right. We have traversed till the second index. So we have traversed the second index, there is no more index in present, so we say no, there is no number present, so you can't traverse anywhere. So it will also return it, right. So it will return, so what it has taken, it has taken 2, right. So it will gonna remove 2 as well. Now we will come to this state. So in this state what we are going to do, we are going to find, now you can traverse to the second index because it has traversed till the 1 index, right. So now we are going to move to the second index, which is 3. So we can append 3 as well, so 1 comma 3, right. And in the 1 comma 3 what we are going to do, we are going to say fine, so we have moved till what index. So we have moved till now second index, right. We have moved till second index, fine. And now 1 comma 3 again I'm going to start traversing nums. So I'm going to say start traversing a nums. So what in nums we have, we have 1, so 1 is already present, it will not gonna take 2. 2 is not present, so it's gonna take a 2. So we are going to say fine, so it's going to take a 2, 1 comma 3 comma 2. And here if we are taking a 2, so we are traverse till the first index, right? Fine. So you can see its length is equal to the num's length, so it also going to append in our result. So 1 comma 3 comma 2, and it's going to return as well. So if it is returning, it's going to remove 2. So you can see we got 1 comma 3, and it has traversed its first index, right? So it has to traverse the second index, so we're going to traverse the second index, which is 3. But 3 is already present, it's not going to we can say recurse again, so fine. And after that there is no more index present, so it's also going to backtrack, it is also going to return. So once it is returning, so it's going to remove 3, right? It's going to remove 3 when we come to this one state, and it has traversed till second index, right? So it means it has traveled the nums complete nums array, so it's also not going to traverse again, so it's going to return as well. So it was taking the first number, right? So it has to remove the one number, so it has removed the one. So now we come to this state, and it has traversed till the 0 index only, it has traversed the first element of nums, right? It's going to traverse the second index. Now it will traverse the second index, it will put 2 because 2 is not present in this one. Now it will keep going to this one now again, so this will happen again, so it will keep going, right? But I hope now you understood the recursion part, how backtracking gonna work. First of all, you're gonna take 1, fine, it will gonna call a new function, it will gonna take 2, it will gonna call a new function, it will gonna take 3, it will gonna call a new function. Then it found that length is equal to num's length, so it's gonna append this array in your result. Then after that, this array, after that we are gonna backtrack, we're gonna move to the back position. So we are gonna remove 3, which we have inserted, we come to 1 comma 2. And after that we are going to backtrack, we're going to remove 2 as well, we will move to the one state now. Then we will found that yeah, one more traverse for this particular array is left, so we're going to move to that apartment. Means simple guys, we're just simply taking a number, we are calling a function, we are taking a number, we are calling a function. After that, once we are backtracking, whatever the number we are adding in our array, we are removing that. Same thing, right? Simple, we are removing, right? I hope it makes sense. Simple thing, guys. Now let's see the implementation part. There you will have better understanding what we can do here, right? How we can implement this particular recursion, right? So what I'm going to do, I'm going to move to implementation part. And here, guys, first of all, I'm with the Python, right? So what I'm going to do in Python, I'm going to say, first of all, define function, that is solve. And you're going to take our temp array, right? Fine. And after that, what I can say, if length of temp, I'm going to write a base condition here only. Length of temp is equal to length of nums. So we can say simply return. But before that, append in our result. So we can say result dot append this temp, right? And I'm going to append like this. All right. After that, I can return it, right? Once this is done, so it's going to return. But if it is not equal to this, so I can say that we are going to, what we are going to do, we are going to say we are going to traverse to the all the possibilities, right? We are going to traverse to the nums array. So we can say, okay, I'm going to traverse to the nums array for I range of, and what I'm going to do, for I range of nums, or I can say simply for value nums. I'm going to check if this value is present in our temp array, so don't take it. So we can say simply continue. But if it is not present, so take it. So you can say temp dot append this value, and after that you can call this function solve of temp, and after that you can remove this function, right? Remove this value, right? Temp dot, we can say pop it, right? So this is going to work, and after that we can say result is initially empty. Let's call this function and let's return our result. Simple, guys, right? Now let's return this. Now let's see whether it's working fine or no. So what I'm going to do, guys, here I'm going to see first of the test case. So you can see, guys, all the test case is working fine, right? So the one way of doing is like this as well, with instead of temp.pop and temp.append, what you can do in Python, you can do like this. You can do like this, right? Temp.value. Fine. Now what I'm going to say, I'm going to say run this code and see whether it's working fine or no. Let me put a square bracket as well. So I hope it should work also. As let's see. Fine. Let's see. And you can see, guys, both the ways are working, right? So you can do any other way. If you're appending the temp, you have to remove it as well, right? Because for next recursion, for next iteration, it should not be present in our temp array, right? Now let's submit this. And I hope, guys, it should also submit, right? And it's successfully got submitted, guys. You can see it successfully got submitted. Now let's move to the next programming language, which is C++. Let's quickly define here as well. So what I'm going to do initially I'm going to say, okay, I'm going to say vector, vector, right? Vector int, and I'm going to say result. I'm going to say vector of int, I'm going to say temp, and I'm going to call this function solve. I'm going to call first of all temp, then result, then nums. Fine, after that I'm going to return our result, right? So now let's define this solve function. So void solve vector of int, we can say temp. We have to use a pass by value temp, and vector, we can say vector of int, right? So vector of int, and we can say this is going to be nothing but our result, and we can say vector of int nums, right? Vector of int, right? Now what we can, so we can say what we can do, we can say simply here if nums of size is equal to our temp dot size, right? So that means we got already all the numbers in our temp array. Fine. What we can do, we can simply say first of all, put this in our result dot push back, and you can push this name, and after that you can simply return your result, right? I hope it makes sense. So after returning not result, you can return nothing because we have make a void function, right? So fine. After that, what we can do, so we can say we traverse over this nums array for int value nums. First of all, check if this value is present in our temp array or not. So we can do like by find function temp dot begin, temp dot end. We can pass value if it is present, so it should not be equal to temp dot end, right? If it is not equal to temp dot end, so that means it is present, so we don't want to take it again, so we can say continue. Otherwise, what we can do, we can simply say temp dot pushback, take this value, right? After taking this value, call this function, right? After calling this function, for next iteration, remove this value. We can say pop back, right? So pop back. Fine. Now let's see whether this is working fine or no. I hope it should work, right? So let's see, guys. And you can see, guys, all the rest is passed. So let's try to submit this code as well, and I hope it will also gonna submit. So you can see, guys, it successfully got submitted. Now let's move to the next programming language, which nothing but we can say Java. In Java, so it's not gonna take a much time, but yeah. What we are going to do, first of all, we are going to define two things. First of all, list of integer, and that is going to be nothing but we can say result, and is going to be new array list, right? Find one more thing, list of integer temp, right? Not list of integer, like this. Fine. New array list. Fine. Now what we are going to do, we are going to call a function where we are going to pass temp, result, and nums. And after that, after this function, we are going to return our result, right? So let's define this function. So we are going to say void, we can say sol. We're going to take first of all temp, so list of integer. So list of integer, we can say temp, and after that list of integer, we can say what we can say result. After that we can say nums array, right? Int nums array. Fine. After that we are going to check if our length, if nums dot size is equal, not nums dot height, if we can say temp dot size, right? Temp dot size is equal to nums dot length. Then what we are going to do, we are going to simply return. But before that, we have to append in our result. So result dot add new array list, right? New array list, that means array list. Fine. So we are going to append this in our result array list. After appending, we are going to return it, right? If it is not equal to the length, then what we are going to do, we are going to set traverse over this nums array, and here first of all check it is present in temps or not. So for that we can use one function, that is contain, right? If our temp dot contain, if this contain value, then what we are going to do, we have to continue directly, right? But if it is not the case, so push in temp. So temp dot add, you have to add in temp. After that you have to call this function temp result nums. After that what you can do, you can simply remove from temp. So temp dot remove temp dot size. How we can remove the last element from temp? We can say calculate the size and do -1. This will be the last index, right? After this, let's see whether it's working fine or not. I hope it should work, right? Let's see. You can see all the rest is passed. So let's try to submit this code as well, right? And I hope it will also gonna submit. So you can see it successfully got submitted. Now let's move to the last programming language, which is JavaScript. And in the JavaScript, first of all, what we are going to do, we are going to say const result is going to be empty currently, right? And after that we can say define one function sol, which is going to be nothing but going to take only one parameter, that is nothing but we can say temp, right? Let me write a const, not. Fine. After that we can say fine. If our sol, we can say if our length, right? If temp dot length is equal to temps dot length. So what we can say, if it is equal, then we can say return, but before that put in our result. So result dot push 3 dot temp, and then you can return, right? After that we can say for int value, not for, we can use a const value of nums, that means traversing over this nums array. We are checking if this value is present in temp or not, right? How we can check that? We can check using an include function. So if temp dot include, we can say what, if temp dot include value, that means it is present. So if it is present, so what we can say continue. But if it is not present, so what we can say, then we can say traverse over this no traverse, append this in our temp. So we can say temp dot push this value. After that call this function. Once we call this function, then we are going to say call this function, and after that once you call this function, you can say remove this temp, right? So you can say temp dot pull, right? Fine. After that we can add, then we can call this sol with the empty array, then we can create our result, right? Let's see whether it's working fine or not. So let's run this code, and I hope guys it should work, right? So it's gonna take a time. You can see guys it's gonna pass all the rest case. So now let's see whether it's working fine or not. So you can see guys it successfully got submitted, right? So it successfully passed all the test cases, it's got submitted. Now we have done the implementation with Python, C++, Java and JavaScript. So guys, I hope you have any if you have any kind of doubt in the problem understanding part, logic part, implementation part, you can write in the comment section. I'm always there to help you. And if you learn something new in this video, don't forget to hit the like button and subscribe my channel. Meet you in the next video.